Hello, Flat Earth researchers, debaters and debunkers. Let's have a look at some examples of just how shoddy the so-called science propping up the globe Earth belief is from this channel, which is ironically named I Can Science That. Now this video is titled Eye Level. The maker claims he's going to do some science to study whether the horizon rises or falls with eye level when gaining height above the Earth, with his very own observations nonetheless. But you'll quickly see for yourself that this, along with many other videos on the channel, is far from scientific. It's actually a great example of the lack of critical thinking, bias and outright obfuscation employed by those wishing to cling on to their ball Earth belief, and who think that science is just finding a way to fudge the results by ignoring what's actually seen in the real world, changing the meaning of words, and dreaming up explanations to fit a presupposed model or narrative. So you can see here that first of all he's talking about the claims that are made by flat earthers, and he said there is some disagreement among the flat earthers as to what actually happens to the horizon. Now he's taken this quote from Eric Dubay: "The horizon always rises to eye level as altitude is gained," and he says that many flat earthers say this is true and therefore it proves that the Earth is flat. But he says that some other flat earthers will say that this is false. The horizon doesn't always rise to your eye level, but they still claim the Earth is flat because the horizon drop is said to be an optical effect. So this could be something to do with the limits of our view or vision when we're actually taking a shot, okay? And then he goes on to say that the other claim that he wants to look into made by flat earthers is that the horizon always appears perfectly flat regardless of altitude. So, okay, you might go high up into the air and you might see this apparent drop of the horizon, but nonetheless the horizon is flat, and because this is seen to be true, this would prove that the Earth is flat according to the flat Earth claims. And then he says that this is sometimes false, that we see curvature. We're talking about this horizontal curvature, but the Earth is still flat, and that's because the horizon curve is an optical effect. So we're talking about things like fisheye lenses which bend the horizon unless you're looking at it straight on at a totally horizontal level. The moment you tip up or down with a wide-angle lens, then you'll get a bend on the edges of the horizon, making it appear either concave or convex. So that does happen. We know that happens when you look through a camera. So ultimately what he has decided to do here is look at these two things. One, the horizon drops with altitude, and then that the horizon always appears perfectly flat even if there is a drop. Alright, so let's just listen to what he has to say about what he's going to do, and then I'll show you how he has totally got it wrong, basically, and hasn't got a clue what eye level actually is. Let's go.
I hope to address this combination in particular. So, does the horizon rise to eye level? How can we test the claim? It's actually fairly easy and has been done to death, but here are a few different suggestions. Install an app on your phone. If you have an Android phone like me, Dioptra is available for free. On an iPhone, theodolite is $8.99. If you don't trust the electronics, you can build a portable water level with $10 worth of parts available at any hardware store. Just get up high and use your chosen tool to measure the angle down towards the horizon. You could go to the top of a tall building, or the next time you fly in an airplane, or use this as an excuse to take a hike up a mountain. I always try to encourage people to go and test this for themselves, but I have had many requests to see my results. Have I actually done this? Okay, here you go. These are the photos I've taken myself. I took a trip to St. Louis and went up into the arch. I used Dioptra to take a picture and showed the horizon below eye level.
So let's stop it there and just go back before changing the photograph. and look at what we see here. So he said the horizon is below eye level, and eye level is obviously referring to this horizontal line here that's part of the app, and it is at 0. So okay, let's say that the camera is facing forward, it's horizontal, it's not tipping up or down, and I would agree that if that was the case, this center point here and this horizontal line is what we would call eye level, and it basically represents how high we are. So you can refer to the eye level as this visual element right in the center of our field of view, as long as that field of view is horizontal, perpendicular to plumb. Or you can talk about eye level in terms of height, and we can see that the altitude here is 996 feet. Another thing we notice about this is that it's very blurry, it's totally out of focus. It seems to be quite a hazy, cloudy day, and we could possibly see a lot further than that if we had a bit more clarity in the weather and in the photograph itself. One thing we can see is that we do see the horizon come up to this point here at least, which is about the height of these buildings here, and you can see it about the same height as that building over there, and even higher than that building over there. And so this does demonstrate the claim in reality that the horizon rises with you or rises to your eye level, because we know that if our eye level was somewhere down here, halfway down this building here, then we would see a horizon at that same height. The horizon is your eye level indicator. It does tell you how high you are in relation to everything else. So it does indeed rise with you. But what about this apparent gap between the surface and the horizontal line referred to as eye level here? Well, if we go and have a look at a different picture taken on a different day by a different photographer. This one is Kevin Ames or Ames photography, and he's at the same location, and you can see here we have a much clearer photograph of the view from that archway, and you can see here that the horizon we see in this case is a bit higher than the one we saw in the other image. We still get cloud and haze in the distance, but we pretty much have a horizon that is a little bit higher than what we see in this photograph here, where the horizon's below that peak of that green topped building there. Let's just go back to this one, and you can see that it's like that. Now in this case the horizon is way up near the top of the photograph, so this instantly tells us that actually he's pointing down. You can see this from the way the perspective works. Everything on the ground here is very spaced out, and then it gets more and more condensed as you get to the horizon. This is how perspective works in our vision. So again, it doesn't matter whether the camera is tilted, really, even if he's got it focused on this building here. The horizon indicates our eye level, and it tells us that we are about the same height as the top of this building here, the top of this building here, and higher than this building over here as the horizon stretches off into the distance. All right, so in this case we have a very poor view, obfuscated by the bad weather and a very unclear, unfocused photograph as well. So now he's going to show us a few more photographs taken from an aircraft, and we'll stop on the last one in that set of photos.
Since I have Doppler on my phone, I always try to check the horizon whenever I get a window seat on an airplane.
All right, we'll stop it there, and we can see that the altitude is about 35 or almost 36,000 feet. And this is a similar shot to the other ones. We have a horizon line, or what is referred to here as an eye level line, that is -2 degrees, so we can assume that he's pointing down slightly, and you might assume from this photograph that you have a horizon that is below eye level. But where is it? We can't really see a very clearly defined horizon. So a couple of things to point out here, and this goes back to the earlier claim in this video that there is disagreement between the flat earthers that we see a horizon drop depending on our height. Some people say we always see the horizon rise to eye level. Some people say we often see a horizon drop as we gain height. Well, one of the big differences here that needs to be clarified is that if you are at a low level, your view of the horizon is going to be quite a hard, sharp line. It's going to look like an edge when you are at a low altitude. But obviously the higher you get, the more air and dust and clouds and haze you're going to have in the distance that basically takes away and erases this hard line of a horizon. So what we're looking at here at 36,000 feet is an eye level that is above the clouds, or a cloud base here, and so those clouds are covering up any horizon on the Earth that we would see, and they themselves create our surface. Because the aircraft is higher than the clouds then become the surface. So we have this very hazy, blurred line, but you can see that it pretty much goes up to that horizontal line there. But either way, we've got nothing that indicates a clear horizon, simply because the surface is clouds and it's all fuzzy, and there is no clarity of the horizon at this height. Now, the next photo he shows us is my absolute favourite because it truly demonstrates the shoddiness of this so-called science. And it proves to me that people like this, defending their belief in the globe and trying to debunk flat Earth and these silly arguments about a horizon drop or not, will do almost anything to fudge the results and make up an explanation that suits the narrative. So we've already established that this horizontal line halfway down, or between the top and the bottom of the view here, is in fact eye level. If the camera is looking straight ahead, then we can say yes, this line in the center of the view is eye level, and I would agree with that. But then see what happens with this next shot using a water level.
Here's my homemade water level up on Mount Wilson. The water is at eye level here, and the horizon is down there.
So you see, straight away you can see that the camera's pointing down, really. We have this water level here referred to as eye level for no particular reason, with no actual measurement, and you can see that it's way above the center of the field of view. And by placing the camera in this particular way, he's managed to make this water level and call it eye level, and say that the horizon is below eye level. This is just an outright lie, and you'll see the people in the comments section just let him get away with it. They're not interested in doing any science, they're just interested in finding ways that they can have an argument with a flat earther without any actual facts, but just an observation that fits their point of view. Now, I don't know why this became fashionable. The only thing I can think of is, or I've seen in certain comments, is that because the flat earther says water is always level, let's use a water level to try and prove a point. So that there isn't anything happening with the water level being put at the camera's eye level. So let's have a look at how this should be done. So here's an illustration of a photographer with a camera that's facing forward, it's horizontally level, and they are somewhere very high up. So where is the eye level in this illustration? Well, there are two eye levels we can talk about. First of all, we have the photographer's actual eye level, represented by this green line that's in line with the photographer's actual eyes. And so the height of the photographer's eyes above the surface is that person's eye level. So this is their subjective view. Okay, they will have an eye level that is in the center of their field of view. But as we're always looking at photographs, let's not use the photographer's eye level. Let's use the camera's eye level, represented by this red line. So as we saw with the theodolite shots, we have a horizontal line across the field of view that is in the center of the camera's field of view, and that is eye level, as long as the camera is facing forward at a horizontal level as well. So this can be the physical height of the camera above the ground, that is the eye level, but optically it is in the center of the field of view of the camera. And now let's bring in the infamous water level. So in the images that we saw just now, the water level was placed somewhere much higher than the photographer's eye level. It was really high up in the camera's field of view. But if you want to talk about the water level being eye level, you then of course have to bring the water level to the exact eye level, or the horizontal line of sight of the camera in the center of the camera's field of view. These two must be lined up if you're then going to compare anything else in the field of view with a claim that it's either at or above or below eye level. So only when you have established that your water level is indeed at your eye level can you then compare it with whatever is in the background. And if we put a scene in here that is seen through the camera lens, you will find that if these two things are aligned, then the horizon or convergence band on the scene in front of you is at the camera's eye level and also in line with the water level, because it has been put in line with the camera's eye level. This is the way you do it, and this is what you will observe. Of course, if you want to get results that fit your narrative and you believe you live on a globe, all you've got to do is put these things out of alignment, and now you have a water level and claim that it is eye level when it's not at the camera's eye level at all, and you've just managed to create a straw man argument. So get your scientific measurements done properly by putting the water level at the same height as the camera's actual eye level. When you do so, that's what you'll see. The scene through the camera lens will show you that the horizon is at the camera's eye level. So this globe earther parlor trick to say that something is at eye level while putting it higher up than the camera's actual eye level, so that the horizon in the distance appears to have dropped below the proclaimed eye level, is exactly the same trick as is used when claiming the horizon drops when seen through a heads-up display. So you might have seen videos by globe-hugging pilots showing you photographs like this one taken through a heads-up display in an aircraft that's traveling at about 45,000 feet. And we see a horizon outside of the aircraft that is claimed to be below eye level. But it's just the same trick as with the water levels. I'll just zoom in here and show you that this horizontal line on the heads-up display is referred to as eye level, when really it's not actually aligned with the camera's horizontal eye level. It's just at some arbitrary place in the field of view and is claimed to be eye level. So then, of course, the horizon appears to be below eye level, when in fact, if you check out these photographs yourself, there are many that you can find, as long as the camera is shown to be horizontal, you will always see a horizon at the camera's eye level, whether it's 40 or 50 or 60,000 feet. Nothing ever changes. So in reality, the horizon does rise with your eye level, and those who want to defend their belief in the globe have to find ways to claim that the horizon somehow goes below eye level, and ignore what happens in reality and how we actually see the world. Thank you very much.